Welcome to our video tutorial here of factoring polynomials, solving polynomials, and really the conjugate zeros theorem. Look at the problem we have in front of us. Perhaps you would like to hit pause and try to solve the problem completely before we proceed together. As we look at this problem, one of the things that we notice is what we are provided a zero of our polynomial, x equals 2 minus radical 7. The conjugate zeros theorem is going to tell us that x equals 2 plus the square root of 7 is also a zero. Based on those two zeros, we can come up with a couple factors. One of them will be x minus 2 minus radical 7, and the other will be x minus 2 plus radical 7. And now we really need to expand that, or to FOIL it out. So the first terms we're going to have x times x, which is x squared. Then we're going to have minus 2 plus radical 7 times x. And then we're going to have minus 2 minus radical 7 times x. And those comes from the outer and the inner terms. And then it's going to be plus 2 minus radical 7 times 2 plus radical 7. So as we continue this out, this will be x squared minus 2x minus radical 7x, make sure you distribute that negative, minus 2x plus radical 7x, make sure to distribute this negative, plus, now these have opposite signs, so this is just going to be, when expanded, 4 minus 7. So we will have x squared minus 4x. Notice that the radical 7's cancel, and then we'll have minus 3. So this quadratic is actually a factor of our polynomial, which means now we can do long division to get rid of that factor from our polynomial. So we're going to long divide out x squared minus 4x minus 3, and we're going to rewrite the polynomial in its entirety that we're factoring. Make sure that if a term is missing, you put in the 0 where it should be. Make sure that you're not making any typos as you're writing it out, because that would get you on the wrong path. And now we're going to do the long division. So x to the 6th divided by x squared is x to the 4th. Multiply everything in the divisor by x to the 4th. And then remember that you subtract, so watch out for distributing the negative as you subtract here. Doing this long division accurately will be essential. Negative 6 plus 4 would be a negative 2x to the 5th. 11 plus 3 would be a plus 14 x to the 4th. And then we will carry the other items down. Then negative 2x to the 5th divided by x squared will be a negative 2x cubed. So we'll line that up in the quotient. We'll multiply accordingly. Those first two things should always match identically. We'll have plus 8x to the 4th and plus 6x cubed. Subtracting, make sure you distribute that negative when you're subtracting. The negative 2's cancel. 14 minus 8 will be a 6x to the 4th. Negative 28 minus 6 will be a negative 34x cubed. Carry the other terms along for the ride. And then we're going to repeat this process. So 6x to the 4th divided by x squared would be a 6x squared. Multiply through 6x to the 4th minus 24x cubed. Oh, that's going to be kind of nice there. Minus 18x squared. Make sure that we're subtracting accordingly. And just watch for silly mistakes as we go. Remember, this should divide evenly. So at the very end, we should have a remainder of 0. It's a nice double check as we're doing this. So here we have negative 34 plus 24 is a negative 10. 27 plus 18 is going to be a 45x squared plus 10x minus 15. Okay, so now we take the negative 10x cubed divided by x squared, which would be a negative 10x. Make sure that we multiply each item in the divisor by the negative 10x. Oh, this looks nice. 45 minus 40. Feeling pretty comfortable that we're making progress successfully. This will be a plus 30x. Subtract those suckers off. The 10's cancel. 45 minus 40 will be a 5x squared. 10 minus 30 would be a negative 20x. And then we have a negative 15 along for the ride. Now when we finish this off, going up in the quotient will be a plus 5. That'll get us 5x squared minus 20x minus 15. We subtract those two things, and notice 5 minus 5 is 0. Negative 20 minus a negative 20 is 0. 15 or negative 15 minus a negative 15 is 0. That remainder should turn out to be 0. So at this point, we have that our polynomial factors, and we have that our polynomial p of x turns into x squared minus 4x minus 3 times x to the fourth minus 2x cubed plus 6x squared minus 10x plus 5. At this point, we need to continue with our quartic polynomial there. And when we look at that, we really need to look at its possible rational zeros. Remember our rational zeros theorem. This one is fairly straightforward. Plus or minus, the factors here are just 1. Factors there are 1 and 5. 1 and 5 are going to be the possible rational zeros. Let's just plug in 1 for fun. 1 minus 2 is a negative 1. Plus 6 is 5. 5 minus 10 would be a negative 5 plus 5 is 0. X equals 1 is going to be a 0, which means that x minus 1 is going to be a factor. Now we only want to work with the part that we still need to factor, which is what I'm highlighting in green. And we're going to take that part that I've highlighted in green and we're going to do synthetic division with it. Remember, if you're missing a term, you have to put a 0 in there. We're not missing a term, so we're okay. Put the value of x that makes the denominator or the factor 0 over on the side. Carry down, multiply diagonally, add vertically. Multiply diagonally, add vertically. And we know what the remainder should be again. It's part of the reason why these problems are nice. Your remainder should always be 0 if you are doing things correctly. Okay. Now we still need to do this again, but sometimes, as we mentioned in class, you might want to watch for a repeated 0. So let's just continue. 1, that'll be a 0, 1. That's going to be a 0 there as we multiply, actually. That'll be a 5. This is going to be a 5, and then there's another 0. Sweet! So we've got that worked out. This is our remainder, and then we have our constant x and x squared. So when we factor this, we have p of x is equal to x squared minus 4x minus 3 times, we had x minus 1, the quantity squared, times x squared plus 5. In this problem, we were asked to determine what the zeros are. Well, if we want the zeros, we're just basically setting that equal to 0. We already know what these two are. It's going to be x is equal to 2 minus the square root of 7. And x equals 2 plus the square root of 7. Those were kind of given to us. We have x equals 1. Don't forget that it actually is a 0 twice. We count the repeats. We count those multiplicities. And then over here, we would just simply say, oh, x squared plus 5 equals 0. So x squared would be a negative 5. When you take the square root on both sides, x is going to equal plus or minus radical 5 times I. So x equals radical 5I. X equals negative radical 5I. If we wanted the zeros of this function, there's 1, 2, 3, 4, 5, 6. And the original polynomial was a 6th degree polynomial. If, on the other hand, we asked for it to be factored, the answer would have been x minus 2 minus radical 7, x minus 2 plus radical 7, x minus 1, the quantity squared, remember we count those repeats, x minus radical 5I, and x plus radical 5I. So it depends on the question. If we were asked to determine the zeros, what we highlighted in yellow would be our answer. If we were asked to factor the polynomial, what we highlighted in green would be our final answer. Regardless, what you have to do is invoke the conjugate zeros theorem, determine what normally would be a quadratic factor that you can long divide out. Remember, your remainder should be 0. Then go look for other possible rational zeros, find some that actually work, use synthetic division accordingly, and at the end, determine your overall answer.